Good morning, friends. Today we'll cover chapter 22, which is Serialization Proxy Pattern. So, as we have seen that in our previous chapter, that using object input stream dot read object is quite vulnerable if the stream of bytes we are retrieving and constructing the object out of it is hacked in some way. So, as we have seen that deserialization of untrusted data can lead to vulnerabilities that allow an attacker to execute arbitrary code. So whenever we decide to implement a class to be serializable by implementing by just using the implements serializable keyword, so it increases the likelihood of bugs and securities problems as it allows instances to be created without the usage of new operator or using constructors, because we are just using the deserialization mechanism to just create the copy of the original object without actually using the standard way of using the new operator or using constructors. Also, the serialized data may contain sensitive information if not protected properly, allowing the hackers to peep in using the security hole. So here, as we discussed that we can have object input filter interface to check on various parameters like the size of the bytes that we are trying to deserialize, or the length of the like the references or the object graphs that we are using, or the serial class itself. The class name itself is like what we want back to be serialized. So all these things we can do. We can actually secure using object input filter interface that we covered in the last chapter. But what if we design a class in such a way that that it's not difficult for it should be very difficult for a hacker to read the object using the object input stream dot read object method. So we can design the class in such a way, our serializable class in such a way by using this serialization proxy pattern. This which actually greatly reduces all these risks because it actually helps to protect this stream of bytes when the read object method is called. The steps to design this pattern is a form of like a template pattern where we actually follow the set of steps to create this type of serialization proxy pattern. So let's go for this like step by step. So I have got this example already here. So I will go through the steps here. So for the first step is that in the serialization Java POJO class, I mean the class which we have implemented serializable interface and we want to serialize it, define a private static nested class with all the fields, all the private field members, same as enclosing class and marked as final. So here, if you see this example, so this is our say Java POJO class, which implements serializable, and we have got all these private field members like string and all this primitive long, double, and boolean. And here, what the first step is that we need to create a private static class member here. So this is our private static class member for market data proxy. I mean, we call this as proxy, which implements serializable. And we have got all these private field members of the enclosing class or the parent class as final here. For example, the same string, long and double and boolean, we have marked this as final inside this inner class, private static class. The second step is also like we have already covered that this inner static class should also implement serializable interface and is called the serialization proxy of the enclosing class. So we're talking about this. So we have already implemented serializable with a new version, serial version UID. And this market data proxy is actually called the serialization proxy of the enclosing class, of the original class. Now the third step is that this inner static class should only have a single constructor for which the parameter type is the enclosing class. So we should not rely on the default constructor. I mean, so we know that in Java class, if you don't define any constructor, then the JVM will also always have a default constructor. A default constructor means that without any argument or without any setting is done. So that is already injected. But if we provide any overloaded constructor on our own, then that default constructor would not be created by JVM by default. So here, this is the same thing. So we are defining this constructor with only like one argument here, one parameter here, which is the enclosing class. So this enclosing class is this one, where inside which we are declaring this. Okay, so this is not the only thing that we have to do. So by doing this, there would be no public, no argument constructor created by JVM because we are already providing one overloaded constructor. Now, the fourth step is to implement the write replace method in enclosing class, which returns an instance of inner serialization proxy class using the above single constructor. So this is what we have defined in third. So now let's go back for a real example here that this is our enclosing class. This is our private static inner class. So in the write replace is called when we actually before it is always called before the write object method. So what it does is that it will replace this original POJO class with the object which is written from write replace. I think we have covered this topic in our previous chapters. So here in the write replace, what it means is that we have to return this market data proxy instance instead of the enclosing class instance. And we are already, this is our enclosing by this parameter. And when we call this new market data proxy enclosing this parameter, so this inner class object is returned from write replace, which is actually serialized, not the original this instance. So this is where what we are creating the object from. This one, and this is actually called from here. Now here is the most important part of this, that we have to implement the read object method in the enclosing class, which should throw invalid object exception, which means that if the hacker is trying to retrieve this stream of bytes and corrupt it by introducing some like malware or virus or something, so we have to throw an exception here that whenever the read object is called on the parent class or the enclosing class, it should throw this invalid object exception, because we are writing our market data proxy as a you can say the proxy object instead of the original object using the write replace, and this market data proxy object is being serialized, and once you want to retrieve it back, it should come the same way. It should be actually coming it. We should deserialize this market data proxy instead of using this read object on the enclosing class. In this way, we are securing our original stream of bytes, I mean the original enclosing class, by implementing it like this way, that we throw the exception if the read object on the enclosing class is being called. And finally, to actually deserialize the original enclosing class, we go where the read resolve method, which is defined in the inner serialization proxy class rather than the enclosing class. This is where the actual magic is happening, that we are securing all these security hacks by protecting our read object method on the enclosing class and doing the same way where the inner static class, which is already private, so it can never be retrieved outside the class itself because it's marked as private. So here we have defined this read resolve inside our inner private static class market data proxy. So here we are defining this read resolve, and then here only we are actually creating the enclosing class object by calling this new operator and setting all these field variables as defined here. By using this pattern, I mean there are a lot of vulnerabilities that is exposed using the read object method, which has been encapsulated here inside this read resolve method of the inner static class, which is not being exposed to the client. So this is what has been defined here, as we had just discussed, that the proxy pattern helps protect the original enclosing class instance to serialize using write replace method, and the attacker cannot get the same instance as we have implemented the read object method to throw exception. And under the hood, it is all the work is done by this proxy class, which is taking care of serializing and deserializing the logical equivalent instance of the enclosing class in a secured way, because we are just copying the same private field members as the enclosing class inside the static nested class, and that's why it's a logically equivalent instance, because anyways the default deserialization also creates the copy of the original object, not the actual object. Now it has also got some very limited two limitations. So it is not compatible with classes that are extendable, which means that if we are having this market data proxy pattern class, and it can be like subclassed, I mean, by using the extends, if we are extending it, so in that case, this proxy pattern will fail, because if we are actually creating this private set in a nested class and we are copying these fields, So it would be difficult to maintain it in the subclasses. So better if we want to use this pattern, then we should mark this our POJO class as final so that it cannot be subclassed. So this is one limitation. Other limitation is that if we have got a class having lot of object references inside it, and those object references called create a circularity. So if we attempt to invoke a method on such an object from within its proxy's read resolve method, we will get a class cast exception because we don't have the object yet, only its proxy. So we have to avoid all this like complex object graphs. If there are there in the parent class, then we should not use this pattern because we may get this class cast exception, because everything we are doing it inside this static nested class, right? And if we will not have that actual object given if there is any circularities there. Thus, consider the serialization proxy pattern whenever we have to write a read object or write object method on a class that is not extendable by its client. Otherwise, we will just override these default behaviors. I mean, the pattern that we have created, and it will not be used. It will not be having like a proxy pattern, but because of these two limitations. Okay, enough of theory done now. Let's dive into IntelliJ and write all these unit test cases to understand this better.